Everyone, it's Mrs. Metler here with our next video, which is about exponential functions. This is actually a new topic, so if you are still looking for ways to increase your grade and you just want to do something so you're not bored, these new topics are for you. So exponential functions are actually really important when it comes to real-life applications. We're going to talk about eventually how exponential functions are used to model things like interest. So anytime you take out a loan, you're charged interest. Anytime you have a credit card, you're charged interest. We're going to do application problems with those so that you guys can actually see and calculate what happens when you take out a lot of loans. It also is used to calculate bacteria growth, decay of material, and also COVID-19 is actually modeled using an exponential function, and there's an article I'm going to post about that later too. So when we have an exponential function, actually any number can be turned into an exponential function. So this b represents any number, and it's raised to the x power. That's an exponent. We are purposely going to focus on 2 to the x and 3 to the x. There's a ton more exponential functions. We just don't have time for them. So I have here our parent functions. We have 2 to the x and 3 to the x. Here are the parent function tables. All right, so if you plugged in 2 to the negative 1/2, 2 to the negative 1, you would get 1/2. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. So I'm going to go ahead and I am going to graph this function to the best of my ability so that you guys can see the shape. And you see here that I kind of have this going on. It grows really quickly. Exponential functions are why we model bacterial growth with these, because they grow quickly. For 3 to the x, it's the same thing, we just have different points. So I have negative 1 is going to be 1/3. 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9. So it is the same model here. It's just this model actually grows even faster. Now, there's an important distinction here to make. These graphs do not cross the line y equals 0 because you can never make an exponential equal 0. There is no number on this earth, if you set it equal to 3 to the x, that you're going to make 0. That's because exponential functions, especially these right here, don't cross this line. They aren't negative. So the continuation of the shape here is just getting closer and closer to 0, but not actually crossing it. If you remember the word asymptote, that's kind of what we got going on here. All right. So what we're going to do is we're going to transform these functions. We actually did this with radicals before spring break, so I'm hoping you remember a little bit about what's going on. So we have a values, c values, and d values. A values are in the front, and they are going to stretch, compress, or we can also call that shrink, or reflect the graph. So it's going to stretch it if a is larger than 1. It's going to shrink it if a is between 0 and 1. So that's like 1/2, 1/3, 1/4. So I'm going to write that here like 1/2, 1/3, etc. And then it's going to reflect if a is negative. If you remember, the a values all affect y. So when we use the transformations, we're going to multiply all the parent functions y's by a. Then we have c values. C values move left or right. We have to flip the sign. So if it's x plus c, it's going to move left. If it's x minus c, it's going to move right. Left and right transformations affect our x values. So let me write that here. X values And, of course, then our a's are our y values. Okay? Then we have d values. This is up. So if we have plus, it's up. And if it's down, it's going to be minus. These are on the end. And, of course, up and down are also y values. So if you remember, we took these and we transformed the parent function coordinates. So what we're going to do is we're going to take every x in the parent function and add or subtract c. And then for y, we're going to take a, multiplied it, then add your d value. So let's look at what this actually does. So if I have this function here, I'm going to highlight my transformations. And I can tell these are transformations because my parent function was just 2 to the x. So anything that changes from that is a transformation. So we have x minus 4, and then we have plus 5 on the end. So we're going to go ahead and look up here. So if I have x minus 4, that's like a c value, and minus is going to move it right. Then I have a plus 5 on the end. That's like my d value. It is positive, so I'm going to move up. So I want to move my graph right and up. So if I'm going to move it right, I need to take all of my x's and add 4 to make them move to the right. All of my y's are going to be added by 5. So this transformation, here's what happens. So if I take all of my x's and I add 4, negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5, and 2 plus 4 is 6. Now I'm going to take all my y's and I'm going to add 5. So 1/2 plus 5, I'll put it as a decimal, I know you guys like that, 5.5. 1 plus 5, 6. 2 plus 5, 7. And 4 plus 5, 9. So let's go ahead and graph this. So I have 3, 5.5, 4, 6, 5, 7, and 6, 9. So you can see my shape. Now remember, in the parent function, I can't cross 0. But since we moved everything up 5, now I can't cross 5. So I'm going to draw my little line here, and then I'm just going to continue my shape, getting close to that line, but never crossing it. Okay, let's look at another one. I'm going to keep this close at hand so we can look and refer to it. All right, so I'm going to highlight my transformations. Those two things are not normal. They are not in my parent function. So I have a negative 1 in front. In front, that's an a value. So negative 1, a is negative. So that means I'm going to reflect. Then I have a plus 3 on the end. Plus 3 on the end is a d value. So I'm going to go up. So I'm going to go up 3. So if I'm reflecting and I'm moving up, I want you to look carefully. The only thing that affects x is c, and we don't have a c value. So both of these are going to affect y. So I'm going to multiply all of my y's by negative 1 and then add 3. My x's are going to stay the same. I'm not moving left or right. So I'm going to multiply by negative 1, then add 3. Order of operations, multiplication comes first. So 1/2 times negative 1 is negative 1/2, plus 3 would be 2.5, since you guys like decimals. Negative 1 times 1, negative 1 plus 3, 2. Negative 2 negative 1 times 2, negative 2 plus 3, 1. Negative 1 times 4, negative 4 plus 3, negative 1. So let's see what happens here. So 2.5, 0, 2, 1, 1, 2, negative 1. And I have my graph now going down. I moved it up 3. So instead of not crossing 0, I'm not crossing 3. And I'm just going to continue my shape here. And I have reflected and moved my graph. Okay, so my next one, I have now all 3 types of transformations going on here. So I have a 4 in front, I have a x plus 2, and I have a minus 1 on the end. So the 4 in front, that is an A value. 4 is larger than 1, so we are going to stretch our graph. X plus 2, that is a C value. Plus means left. And a minus 1 on the end, that is a D value, so we're going to go down. So this means I'm going to go left. So I'm going to subtract 2 from my x's. I'm stretching my y's and moving them down. So I have to stretch them first, then move them down. So I'm going to subtract 2 from all my x's. So that would give me negative 3, negative 2, negative 1, and 0. And then I'm going to stretch and move my y's down. So 4 times 1/3 minus 1 is actually just going to be 1/3 again. 4 times 1 minus 1 is 3. 4 times 3 minus 1 is 11. 4 times 9 minus 1 is 27. And as you can see, we grew super fast. So that's because we are stretching. And I'm sorry, 4 times 9 is actually 36 minus 1, which is 35. We're growing super fast. Okay, so negative 3, 1/3, negative 2, 3, negative 1, 11, and I'm already off my graph. Now we move down 1, so that means our line is going to move down to negative 1. We're going to get very close but not actually touch it. Okay, last but not least, we've got a lot of transformations here again. So I have a 1/2, x plus 1, and minus 7. I want you guys to pause and think about what each one does. So the 1/2 is an A value. That is between 0 and 1, 1/2. So it is going to shrink, which means we're really growing shorter. Hopefully we have the hang of the x plus or minus by now. So this is going to move left and then down. So my x's are going to move left, so subtract 1. My y's are going to shrink and then move down. So subtracting 1 from all of our x's, or moving them all to the left, and then stretching and moving down. So I have 1/2 times 1/3. 6 minus 7 would be 6 and 5/6. And then I have 1/2 times 1 minus 7. And these are all negative. And then I have 1/2 times 3, 3/2 minus 7. And 1/2 times 9, so 9/2, which would be 4.5 minus 7, so negative 2.5. As you can see, we're definitely not growing as quickly anymore because we did shrink this graph quite a bit. And so the rate of which we are growing is not quite as quick as it might have been before. So as you can see here, I have shrunk my graph a little bit, and then I am not going beyond the line -7. And there is my line. So go ahead and rewatch this video a couple times. It might be pretty helpful to go back through. It might also be helpful to write this down on a separate piece of paper, especially when you take your quiz. So join me again for our next video.